All right, when we left off last time, we were talking about functions, and we had gotten to a point on one where we were looking at values in the domain, I believe. And here's where we were. Examples 9 and 10. And it asked us to write these as an interval, and that's what we hadn't done yet. So we've written what the x values can be, we've written what they can't be on the second example, and we're going to write an interval. And to kind of show you how that works, although the directions don't say that we're going to draw a number line and shade inequalities and so forth, I think it'll be helpful to sort of see where the intervals are coming from if I do that. So I'm going to show you this part. If when you're doing your work you don't need to see this, I mean, you don't have to do this part of it, but I find it helpful, at least for right now, for us to consider this possibility. So when we were looking at inequalities at the very end of our last unit, we talked about how we would graph them, and in this case I have, it's positive 6. And I'm supposed to be taking a look or thinking about the values that are bigger than 6, which means which direction would I shade if I were shading on this number line? I would be shading to the right. So, let me change that color. Okay, so I'd be shading this direction, right? And would I be using a parenthesis or a bracket? Parenthesis or a bracket? A bracket, right? Because it says less than or equal to, and it would open in the direction of the shading. So when I had done this with you guys before, the reason that I had liked using the parentheses and brackets was because of what we're going to do next, actually. It's the interval part. So if I were to take this set of values and I were to write an interval notation for it, it would mirror the brackets and parentheses that we used on the number line. So it would start with a bracket. I meant to do that in regular pen. Start with a bracket, and we would put the number that comes next, or the number that it represents, 6. We'll put a comma, and then we'll put an ending value. Now, this one's shaded to the right forever. So what do you suppose we might write instead of a numerical value for the ending value? Infinity, right? And we can't actually equal infinity, so anytime we have an infinity, we're going to put a parenthesis. So this is what the interval would look like for this particular set of numbers. The next one doesn't exactly mirror the ones that we were doing before with intervals, but it works the same way. If I were to draw a number line, and I were to mark the number 8 on it, and if I were to shade the values that represent everything but 8, then I would shade to the right and I would shade to the left, but I wouldn't actually include the number 8, correct? So if I were to think about it this way, I would have parentheses nearby 8, because parentheses mean we don't include it. We leave it out. And this would be the shading for the number line. And then in interval notation, that would mean that I have 2 intervals with parentheses. Do you need to leave? Probably should, yeah. And the 8 would be the end points of those 2 sets of parentheses. We have already done one that looks like the one on the right, where it goes to infinity. What would we do on the left side? Yeah, we would do negative infinity. And again, parentheses. Some resources will have you put a U in between these. If you want to do that, that's fine. You can put a comma or you can put nothing. I don't really care. It doesn't matter to me. But these are the 2 intervals that would include everything but 8. So when we're looking at intervals, which we're going to continue to use this notation a lot, that's where it's coming from. It's from how we were thinking about our number lines from before. All right, I have a couple of more examples in this section, and so we're nearly done. Any questions on these 2, though, with the interval ideas before we move on? Okay. We're going to look at the next one to determine if, in fact, we have functions. Now, it's been a couple of days, and you've had a test in between now and then, so go ahead and jot down my questions, and then I'm going to flip back to the definition on my slides to remind you how we defined a function. Okay, so when we defined function way back at the beginning of this section, we talked about the fact that it was a relationship between inputs and outputs. When it's written in equation form, that would mean between x's and y's, where every x value or domain value or input value has one and only one output value. Okay? We talked about that in terms of graphs, in terms of tables, in terms of ordered pairs, and we're going to look at it now in terms of actual equations. So if I were to consider, we're just going to look at part A, this equation. If I were to put a number in for x and I were to solve this, so somebody just give me a random value for x so I can show you how you're thinking about it. 2. All right. So if x is 2, so I told you a random value, but 2 is not my best random value. And I'll explain why in a second, but let me use 1 first, just because I don't want you to think weird things are happening with the 2. If I used 1, we would have 1 squared is 1, right? So this is 1. And if I were to subtract it from the other side, I would end up with 7y equals 3. And I would divide by 7, and I would end up with y is equal to 3/7. How many values did I get for y when I put in 1 value for x? Just 1. The reason I'm not super fond of the 2 you gave was because I would end up getting a 0 on the other side, and sometimes zeros end up doing weird things. I'll go show you an example when we get to another one later on where that's the case. But no matter what value I put in for x, even if I put in the 2, how many values am I going to get for y? Just 1. The process would be the same. I would subtract whatever that x squared ended up being, and I would divide it by 7. I would always get 1 value. So every 1 input gives me 1 output. So this one's a function. But I'd like to try the same thing on part B. Okay? We'll use the same x value. We'll use the same x value where it's going to cause a problem, but that's okay. We're going to use the same x value, and I'll show you the problem, and then we'll use a different one. Okay, if I try this one right here, x is 1, I end up getting that the absolute value of y would be equal to -1, right? So what would y equal in that case? No solution. All right? No solution's fine. It's not more than 1 value for y. It just wasn't a good choice for x. So I'd like to pick a different x. Is it okay with you if I pick -1? Okay. If I pick -1 instead, I would end up getting a +1 over here, right? If that's my case, what values do I get for y? Yeah, y could either be 1 or -1. So I had 1 input for x that gave me an output, but it gave me how many outputs? 2. It gave me 2 outputs. Back to why I don't like zeros. I'm going to show you the example with this one that if you don't choose sort of well, you might end up with a problem. If I put in 0 for x, I would have the absolute value of y is equal to 0, and what would y equal? 0. So sometimes zeros actually give me 1 value for an answer when most other values would have given me 2. Does that make sense? So I kind of, if I'm arbitrarily trying to guess, I want to try and guess things that are not going to sort of wind up with zeros at the end, okay? So in this case, what we do see is that most y values, most x values that I choose, if I chose x is equal to -2, x is equal to -3, in all of those cases, I'm going to get 2 y values instead of 1 y value. So is it a function? No. In order for it to be a function, I can't have 2 y values coming out, right? The outputs have to have 1 output, not 2 outputs. So this right here, this is the one that shows me the real problem spot, tells me that it is not a function. The last one on here, we'll talk about what this is an equation of in a minute. Let's try this one. If I were to choose a value for x, So somebody give me a value for x. Please don't give me 1, because 1's going to produce some zeros. Choose something different. 7. Okay, 7 squared plus y squared equals 1. Okay, so I don't know why I keep asking for arbitrary values. This is going to be a problem too, but we'll just go with it so you can see what you do when there's a problem. Here's 49 plus y squared equals 1. What would I do? I would subtract my 49. What would y give me, or what would that give me on the right? Negative 48. And if I take a square root, what happens? It would be imaginary, right? And we're working right now in only the real number system, so this is no solution for the real numbers. Now, I had no solution with my absolute value before, and I told you that doesn't really help me. No solution doesn't give me any real information. You could be a function and get no solution here, or you could be not a function and get a no solution. So this is not useful information. I need to pick a different value for x. The one I was wanting to avoid, which I'll use right now just so that you can see what happens if I try it, is x equal to 1. If I use x equal to 1, what would I get? And what would happen next? Yeah, I would get that same, y value, something of the y value equal to 0. And if I take a square root of 0, I get, it's a number, but it's just, it's 0. The square root of 0 is 0. So the thing that normally happens when we have square roots is, what do we have to put in front of them? A plus or minus. But what's plus or minus 0? It's just 0. So I only get one solution out of this. Let me choose another option that actually won't give me no solution and won't give me 0. You're not going to like it, but we're going to do it anyway. We're going to choose x as 1/2. You guys don't like fractions, so use a decimal if it makes you feel better, but I'm going to use 1/2. What is 1/2 squared? It's not 1, but it's 1/4. Yeah, you just square the top and square the bottom. So what was already a fraction that you weren't super fond of is now an even smaller fraction, right? That you're less fond of. That's okay. You can handle it. I know you're okay with it. All right. What would I do with the 1/4? I'd subtract it. So what would the y squared equal? What's 1 minus 1/4? What is it? 3/4. Think money, right? $1 minus 1/4 is 3/4 left over. Like that, 3/4. I would take a square root, but you told me just a minute ago what happens when I take square roots. What do I get, though, in front of it? The plus or minus. Sorry, I couldn't hear you very well, Jonah. Yeah, plus or minus. So I don't really need to solve this. I just need to recognize that at this point, how many answers do I get? 2. And 2 answers mean what? It's not a function. So this one as well is not a function. So I'd like for you to jot yourself down a note. If it's not a function, if you're telling me this is not a function, you need to show me a value that makes that happen. Okay? So you might have to play around with them. I chose 3 values before the one that showed up that it really was not going to work for. In particular, though, things are not going to be functions when you have y squareds and absolute values of y. That's when it's going to happen. Okay? So if you're seeing absolute values around y, or you're seeing squares outside of y's, you probably have things that are not functions. You just need to find a value that shows me that. That's the work you would need to show. So do you need to show all of the work here at the bottom? No, if you were better at choosing values, then you should only need one value. That last one is the one that does it in both cases. Okay? Well, the last one in the second case that I just did here on part C. On part B, it was the second one I picked. But are you guys good with that? That's how you justify that it's not a function. All right, one more example. I know word problems are your favorite. I have a friend at church whose son is homeschooled, and they're just struggling with pre-algebra ideas right now, and this idea of why slope matters. And I didn't really talk too much to her about it because she really just wanted to vent. She didn't really want my input. But slope is really just how things change. It's just how things are changing. And this is a really good example of an application, real life stuff, where there's a slope and it's representing how something changes. So let's take a look and I'll show you what I mean. Eric received a $50 gift card for a photo center. He bought prints costing 8 cents per print. His balance, B, after his purchase was B of X equals 50, that's the $50, minus 0.08. Where'd the 0.08 come from? It's 8 cents in dollar form, right? X. And it's coming from, and why is it's multiplied by X? Because X is it's the number of prints. And the question is, what is his balance after buying 20 prints? So in this equation, what is the slope? What is the slope? It's the 0.08, right? You think about your equation, y equals mx plus b. Slope is the number multiplied by x. So it's the negative 0.08 in this case. That's slope. And all it's showing is how his funds on his card are changing, right, with every print he purchases. Every print he purchases subtracts 8 cents from his card. Okay? This is what happens when you swipe your debit card or your credit card at a gas pump or at Walmart, right? It takes something off of it. Okay, this time it's taking a consistent amount, 8 cents off for every print. The question asks here, what is his balance after 20 prints? So what is this question asking us to do? It's a really pretty direct question, but it's wordy. What's it asking you to do? Yeah, it's asking you to plug the 20 in for X. Remember, the left-hand side, this is just another name for Y, right? It's an alias. You probably have more than one name that you go by with different people in your life. You can think of 3 in mind that are common. My first name, Krista, or Miss Krista if I'm at church. You know, kids do that, right? Dr. Hands when I'm here for the most part. And Mommy. Mommy, Mom, Mama, they're all the same, right? Those are my 3 basic names. B of 20 is just another name for Y. It's an alias. And I need to do 50 minus 0.08 times 20, right? There's 20 prints, 8 cents per print. So if I were to evaluate this, and you're welcome to grab your calculator to do it, doesn't bother me, how much will be left on his card after his 20 prints have been purchased? Need a value? $48 and what? 0.4? 40 cents left over. $48.40. Does that look good? Okay, so was the word problem hard? They gave you the equation, and they gave you the input value, and they're just asking you to interpret what to do, and then evaluate it. Please do be careful that if there are units, in this case, there are, because you're working with a context problem, that you use them. So this is dollars, right? So we include the dollar symbol. Any questions on this? All right.